bato, roca, sakhar, bawi, whatever you call it, this element is a common sight for us. We are mesmerized by its beauty, but sometimes we don't even show our eyes on it. However, rocks can be so much more. They hold wonders we can be curious about and experiences we can learn a lot from. When rocks shift, they can remind us of their immense power, sometimes leading to natural events that impact our lives. These hard materials also preserve the stories of our planet, holding within them the very essence of Earth's history. Do you want to get to know them more? Then let us dive in and follow the tale of a rock.
Good morning, Philippines. It's 4 minutes past 8 in the morning, September 12, 2024.
This is Zoe Tanchonko.
And this is Daphne Denisa, your newscasters for the Rock News. Ever wondered what happens under what we're stepping on? Today is a great day to explore your minds with the mysteries of the underneath.
Reporting from the Earth's interior, Sean Magsanggol.
What's the news there, Sean?
It's getting hot in here, man. This intense heat in the Earth's interior, its mantle and the core, is primarily due to the decay of radioactive elements like uranium, potassium, lead, and argon. Undergoing radioactive decay, it releases heat as they transform into more stable isotopes, representing 90% of the Earth's total heat. One more factor is the consequences of its formation. After the creation of our solar system, the gravitational pull attracted meteorites and larger celestial bodies until our planet grew to its current size. This process accumulates heat. When two objects collide, heat is generated. This heat is responsible for about 10% of the Earth's total heat.
Hey, that's some cool info you got there. But I thought it was the magma on Earth.
Actually, the heat produced by the Earth is the main reason why magma is produced and why magma is hot. Well, magma was also formed due to the melting of rocks in the Earth's lithosphere, which is the lower Earth's crust and upper part of the mantle.
Oh, but I wonder what happens after the magma is formed. What do you think happens, Sean?
Once formed, magma often becomes a lava. Magma rises upwards and eventually escapes the Earth's interior through a volcano or cools and crystallizes, becoming an igneous rock. But do you know the layers present in the Earth?
Oh yes, the inner core, the outer core, mantle, and the crust. But what about it? And that's for the next headline. Thank you, Sean. I was thinking coming from the Earth's crust.
For the headline, the 4 layers of the Earth. What it is, what's the difference? Ian Palma coming for the report.
Pleasant morning. This is Ian reporting. The inner core, Earth's super hot, super solid composed of iron and nickel, is burning hot as me. As for the outer core, the only liquid layer of the Earth is also composed of molten iron and nickel. It is liquid due to the Earth's hot temperature, yet can carry the Earth's weight due to its higher density compared to the mantle and the crust. As for the mantle, it is the layer beneath the crust. It is composed of hot, semi-solid rock that flows slowly. Also where magma can be found. Last but not the least, the crust is broken into pieces called plates. It is divided into two, the continental crust and the oceanic crust. The continental crust is composed of granite, which is lighter than oceanic crust, which is composed of basalt. Back to you, Dap.
Thank you, Ian, for that report. For the adventurous scientific report we have for today. Wrapping up, this is Zoe Tanchonko and Daphne Denisa. In the world of geology, learning is our utmost priority. Signing off, The Rock News.
Hello, and welcome back to Fast Talk with Tito Boy. Today, we have a special guest that knows the wonders and magic of geology. Please welcome the amazing Daph. You're welcome. Please have a seat. So, how long have you been a geologist now?
Like 5 years now?
Lovely. And since it's your first time here, we're gonna do Fast Talk with Tito Boy. We'll set a timer and your job is to answer as many questions as you can. Ready, Miss Staff?
Ready.
Let's go. Sedimentary rocks, hard and formed.
Compaction squeezes sediments together, then cementation glues the squeezed sediments together.
Are there any classifications?
Yes.
What are those?
Vertical rocks, which are formed from erosion, which causes a compaction and buildup of raw materials or debris. Then chemical rocks, which are formed from dissolution or precipitation of minerals.
Igneous rocks, hard and formed.
Through cooling and solidification of molten rocks or magma and interstellar debris. Volcanic rocks are when magma reaches the Earth's surface, and volcanic rocks, which are created within the Earth.
Metamorphic rocks.
Through intense heat, pressure, or chemical changes.
Is that categories like the other two?
Yes, foliated metamorphic rocks are that have layered or banded texture, while non-foliated metamorphic rocks do not exhibit any layered or banded appearance.
How do rocks undergo weathering?
Through processes that break them down into smaller pieces or change their chemical composition.
What are these processes?
By physical, chemical, or biological weathering.
How does erosion carry away those products of weathering?
By water, wind, ice, or gravity.
And where does it all get deposited?
On new surfaces like riverbeds, ocean floors, or deserts.
Wow, that's so quick. But wait, what's your favorite rock type?
Metamorphic rocks, because even under intense pressure, it can turn into something more beautiful and greater just like us.
Wow, now that's some deep insight. Thank you, Miss Geologist, for that rock solid explanation.
Thank you po, Tita Koy. Thank you, everyone. Thank you for having me here.
And that's a wrap for today's Fast Talk with Tito Koy. And remember, just like rocks, we all have the potential to transform and shine. See you next time!
What's up, the rocks people? Woo! Bursting down with this enthusiastic energy, this is Zomitan Chonko, and welcome to the Rock Showdown, the ultimate finale. Here we have players on fire, ready to blast this place down. Presenting the duo from AP schools who won countless science Olympic competitions, second to none, J.Ann Nagalapak and Dap Asines. Stop Asines. Representing AP schools, Mabuhay! Inside, the heartthrob students from East University, known for their jaw-dropping looks, Jacob Blogmosgab and Matthew Amla.
Good day, ladies.
I am Matthew Amla.
And I am Jacob Lobosgab, and we are the representatives for the EC University. Sui!
Wow, what a powerful intro for both sides. With no further ado, buckle up as we witness the world's most ultimate showdown. Winners will be granted a free ticket to visit the Rocks Laboratory to witness and learn more about rocks. So, players, all ears.
Here's the title of the game. Flip the coin, heads or tails. We have a coin that will be tossed, and all you have to do is guess which side will be showing once the coin falls on the hand. But each pair should guess different sides, either heads or tails. The duo who gets it right will be given the chance to answer the question first, and if their answer is incorrect, the other duo will automatically be able to steal the chance of answering the given question.
The mechanics of the game? Yes! Okay, let's start. For the pair who guessed correctly, here's your question. How do rocks behave under different types of stress, such as compression, pulling apart, and shearing?
Stress, the force acting on rocks, can cause them to deform in various ways.
Compressional stress, it pulls the rocks together, causing it to fold or fracture.
Tensional stress, which pulls the rocks apart, can cause them to elongate or even break.
Then lastly, shear stress, it forces them to act to the opposite directions, causing it to slide past one another, often forms fault or earthquake.
Okay. Here's your question. How do rocks and soil move downslope due to the direct action of gravity? Explain.
Basically, logically speaking, it's due to mass wasting. It occurs when gravity overcomes the force holding the rocks and soil, causing them to fall downward, such as steep slopes and the weight of rocks and soil. The heavier it is, the more gravity pulls them.
Mass wasting events can also be triggered by rapid snowmelt, intense rainfalls, volcanic eruptions, earthquakes, and human activities.
Ikaw muna, Well, 1 point for Team EC University. Oh, it's a tie. To break this tie, here comes the last round, the finale. Viewers, can you feel the pressure? Dear contestants, inhale, exhale. Okay, here's the question. Can you describe the changes in mineral components and texture of rocks due to the changes in pressure and temperature in metamorphism?
Metamorphism is like a rock's makeover. It changes physically and chemically.
Because of the pressure underground, it compacts the minerals in the rock, changing its form, making it look squeezed. Its minerals can also change. It may rearrange themselves, break, or even form new minerals. Fun fact, because of the intense pressure, charcoal can turn into a diamond.
In metamorphism, temperature has a huge influence, especially heat, because it can be unstable and rearrange themselves. Its heat also forms a new mineral.
The answer to the question is correct! That was nerve-wracking. Congratulations, Jayan and Dap Dap, for winning the grand prize. And as promised, here's a visit to the laboratory. Wow! I'll leave you both in good hands. Enjoy your time here.
Wow! This is so cool!
Welcome to the lab. Feel free to roam around. We're here. We have different rocks.
But sir, rocks don't move. What are we supposed to do here? Can you tell us some interesting facts?
Sure. Did you know that rocks have their own ages?
Really?
Yes. Look at this.
Which do you think of this is the older one? Do you think it's the left one? Okay, let's go with that. Mister, I'll choose the left one.
Then I'll pick the one on the right.
Very good, JR. This rock is indeed older. But do you know why?
Why?
There are two ways to determine the age of stratified rocks. The first is called relative dating. For this, we look for clues like fossils within the rock, and this method is called stratigraphy. And the second method, absolute dating, measures the decay of elements within the rock. This method is proven to be more accurate.
Oh, I see. Rocks are all different, right? Especially the rock-forming minerals.
Yeah, great question. Just like their age, rock-forming minerals can be identified through physical properties and chemical properties. You might want to list them down. For physical properties, you can look at color, crystal habit, luster, hardness, cleavage and fracture, streak, texture, and density. Meanwhile, for chemical properties, you can observe their chemical composition, crystal structure, solubility, and melting point.
Wow, that proves that even though rocks are small and hard, there's so much more to them.
Well, aren't rocks supposed to be huge? All I can see here is the small samples.
Maybe they're too big to fit here, dog.
Speaking of huge rocks, they are actually the reason why earthquakes happen. If you look here, these huge rocks are actually called tectonic plates, and earthquakes happen because they move around.
Are earthquakes the only result of this movement?
Actually, no. Plate movements can also cause tsunamis, volcanoes, mountains, trenches, and many more, depending on the type of boundaries between these tectonic plates.
Wow, I'm learning so much. I love winning. I hope all prizes are like this one. Wait.
Sawa ka na ba sa mga bola? Or maybe you're tired of seeing misinformation spread online? Well, don't worry. You can always count on us here at Fact or Bluff to set things straight. Here, check this out. Hello viewers! Welcome to another episode of Fact or Bluff, where we'll debunk all those misinformations over social media. Educational videos are seen everywhere on the internet, especially on YouTube and TikTok. However, are these informative videos fact or bluff?
Do you know how index fossils play a significant role in organizing geological timescales? Through the record of a specific fossil, it has the ability to tell the researchers or scientists about the environmental state. This nature's way of investigating from the past. It has a subdivided unit, which is identified through layers of fossils, and this helps scientists to identify the beginning and end of time. It's like Earth is keeping everything organized, but instead of using folders, it uses fossils.
A lot of you mentioned me on this video, saying that we went through the bus, this is a funny translation, but this pieces of information are definitely fact. Fossils can be used to identify the future and that's something that's wrong.
Okay, let me just share something. Someone asked, Ate, can you explain what is ocean basin for? So let me explain. Ocean basins are formed because of divergent boundaries. Once the tectonic plates move apart, it will create a hollow space that will be filled with water. Therefore, you can imagine it as a giant bowl filled with water at the sea. Well, actually, there are 5 ocean basins recognized by the United States. These are Arctic, Atlantic, Indian, Pacific, and Southern basins. Hope you learned something.
That ocean basins are discussed in high school. Everyone must know this. Let's try the other one. This video was very cute. The real farming is super creative and engaging, especially for the students who have low attention span. Well, this video is only speaking facts. Now let's try the other one.
Ever wondered why continents are far from each other? Well, let me introduce to you the continental drift theory. This theory is proposed by Alfred Wegener, and one of the pieces of evidence into this theory is the jigsaw puzzle. The jigsaw fit of continents, particularly the western coast of Africa and the eastern coast of South America, proves that they were once connected. Moreover, there's the magnetic reversals. The Earth's magnetic field has reversed polarity many times throughout history. Finally, the fossil evidence of identical species on now separated continents and discovery of similar rock types and ages on different continents, such as those found in South America and Africa, further supports this idea. Follow for more.
The video is very AI, and a lot of videos like this are sometimes inaccurate, right? But this content is definitely a fact. It seems like the internet is slowly turning into a better place to learn. That's it for this episode. See you for another Fact or Bluff next week. Bye! Rocks are truly the manifestation of magic with its different characteristics and kinds. Like us, they endure pressure, adapting, and emerging stronger. So next time you see a rock, think about your own journey. How have you transformed under pressure? What kind of rock would you be?